From the previous video, we have learned the sequential API. It allows us to build neural networks by stacking different layers together. In this video, let's explore functional API. It helps us to build more flexible neural networks. This is an overview of this video. First, we'll go through the paper, Wide and Deep Neural Network, and talk about the theories behind it. It was introduced by Google in 2016 for their Google Play App Store recommendation system. If you have no interest in the paper, please skip it and jump into the practical example. Second, we'll use Keras functional API to implement wide and deep neural networks. Third, Keras functional API allows users to configure a more flexible neural network. We'll explore the multi-input and multi-output architecture. Let's get started. First, this is the original paper. Wide and deep neural networks help increase user acquisition rates on the Google Play. In other words, they build a better recommendation system from it. Let's take a closer look at this paper together and understand how the wide and deep neural network architecture works. Memorization can be loosely defined as learning the frequent co-occurrence of items or features and exploiting the correlation available in the historical data. Generalization, on the other hand, is based on the transitive of correlation and explores the new feature combinations that have never or rarely occurred in the past. Here is a visualization of the architecture. This is a wide model. It contains lots of neurons in one layer, and it is better at memorization. This is a deep model. It has multiple layers, and each layer contains less amount of neurons. The deep model is better on generalization. We can combine both of them to achieve a wide and deep model, and we can get the model both good at memorization as well as generalization. Continuing in the paper, the wide component is generalized linear model of the form y equals w transpose x plus b. The deep component is a feed-forward neural network. Essentially, wide and deep neural network connects part of the input directly to the output layer and use part of the input that feed through the neural network. Now we have the impression of a wide and deep neural network. We can use functional API to help us build the model. Our goal is to connecting all or part of the input directly to the output layer, just like mentioned in the paper. We will continue to use the California housing dataset to explore the functional API. This dataset contains 8 features. After we separate the entire dataset into the training, validation, and testing set, we can start to build a neural network. This part of the code is pretty similar to the sequential API. First, we create all layers definition, a normalization layer to normalize the data. Then, we create 2 hidden layers with 30 neurons and a relative activation function. The concatenate layer allows us to combine different inputs together to feed them into the next layer. The final output layer has 1 neuron without any activation function, so it can produce any number. Based on the previous layer definition, we create instance based on the definition. In order to handle the data input, we create this input layer and make sure the shape is correct so that it can process the data. The norm instance created, and we pass the input layer to this norm layer. We use a normalization layer just like a function, passing the input layer as a parameter. This is the reason why it is called a functional API. This line connects the norm layer with a hidden layer 1. Hidden 1 is connected to the hidden 2. The concat layer concatenates the normalized input layer with the hidden 2. It becomes the input for the final output layer. Keras provide API and we can visualize what this model looks like. This is actually what we want. After normalizing the inputs, the normalized layer goes through two deep layers and concat with the normalized layer again for the final outputs. We can use the summary function and show the internal parameters. After we build the model, make sure you use a normalized layer to adapt the training set so the data is normalized. Calling the fit function to fit the training set and get the evaluation result from it. There are some cases where we decide to use a subset of features to go through the wide model, and another set of the features go through the deep model. Functional API can help us to achieve it as well. First, we separate the training, validation, and testing sets into two subsets. The wide sets contain the first 5 features from index 0 to 4, and the deep set contains the last 6 features from index 2 to 7. We have 2 inputs to receive those subsets, and 2 normalization layers to normalize those inputs. The input wide is normalized by the norm wide, then connected to the concat layer. This norm deep is connected by the hidden 1 first, then hidden 2. The concat layer concatenates both wide and deep together for the final output. At the end, the first 5 features are the wide part. The last 6 features are the deep part. Make sure we include the 2 inputs as the inputs parameter. Let's take a visualization of this multi-input neural network. It looks exactly like what we expected. First part has 2 dense layers, and the second part directly connects to the concatenate layer. This code block is pretty similar to the previous example. Make sure we include 2 different inputs for the model fit and the model evaluate function. Next, let's take a look at the multi-output model. In certain scenarios, we want our neural network to perform multiple tasks on the same data. For example, we want our model to estimate houses' price value as well as estimate their rent price. We can definitely create separate models and perform each task for each model. However, in some cases, a single multi-output neural network can learn features which are useful across tasks. The multi-output model may give better results than multiple individual models. Here is a code example for multiple outputs model. It is pretty similar to the previous example. The difference is that we add this aux output as another output from the model. This aux output layer is direct output from the second hidden layer. We can verify the structure from this image. Input deep features will be passed through the deep neural network and output aux output. Input wide features will concat with the deep neural network and output another result. Now we finish the model construction. We can train the multi-output model. Because our model has 2 outputs, we need to make sure the 2 loss functions. The loss weight parameter allows us to adjust the loss ratio. In our case, we care more about the output than the aux output. So we set a much higher value for the output. Make sure we use the correct label for each output. In the real-world project, the first Y should be the label of the actual house price, and the second Y should be the label of the actual rent price. We will use the same Y here for demonstration purpose. After the training, we can evaluate the model performance on the test set. Now, we have built various architecture with the functional API. I hope you have learned the functional API. This is the end of this video. If you have any questions, please leave it in the comments below. Please consider like and subscribe, and I will see you in the next video.